Hello, this is AP Physics Kinematics Review, Unit 1. First of all, understand the concepts of vectors and scalars, which is very important. Vector is something that is a quantity which has both magnitude and direction. Scalar is only magnitude. For example, on a displacement and velocity, where those are vectors, we have the direction positive as right and up, negative as left and down. Keep that in mind to put a negative sign. So a negative sign in physics just tells you that is the direction, going in the opposite direction. Scalar, it has only one magnitude. That's the quantity that possesses no direction. Example, distance and speed. So if you would think of the difference between a distance and displacement, displacement is given by final position minus initial position. So if you are starting at a point and coming back to the same point, though you covered like 1,000 steps, your displacement is still zero because both the positions of initial and final are zero. However, your answer for your distance for the same problem would be 1,000 steps. So keep in mind, we always do the absolute values for the distance and speed because we don't consider the direction. So we don't put any negatives on it. Okay, next comes some problems you will be involving dot diagrams where you asked you to analyze whether it's speeding or slowing down. If you frequently see the dots, what does that tell you? The position is occurring like faster, right? Whereas you see the dots not very frequently, that tells you that it is in a slower pace. Just keep that in mind. Okay, next we have these formulas that you have to kind of know, where we generally will have from even like basic physics or science. Speed is equal to distance over time, and velocity is also displacement. I'm putting a vector there to tell it's a displacement over time, and acceleration is basically your change in v over time. So you know that, right? So this is rate at which the displacement is changing. Acceleration is the rate at which velocity is changing. So we will also analyze some motion graphs from this. So the next topic is the motion graph, where we will be relating how position, time, velocity and acceleration are related. So if you would see that if my position is at a linear, constantly changing at a constant pace, right? The rate at which it's changing is constant. So the rate at which velocity, this position is changing is just velocity. So basically, you need xt these graphs to find your velocity and acceleration from your x. You're going to look at their slopes. Okay, and if you look at the slope, it's a positive slope, so velocity is going to be positive. Okay, and since velocity is constant positive, my acceleration is zero in this case. Same way, if you look here, my xt curve is not it's not moving at a constant pace. That is kind of like if you see a concave up or a concave down, you see that it is not at a constant rate. So, but though, however, it has a positive slope. So, which means, just keep in mind, if you are in calculus, you know that if you have a rate of change that is like concave up like that, you will know it's a positive slope that represents your velocity. So your Vt is a positive rate of change. Since Vt is accelerating linearly positive, your acceleration is positive. Okay, and let's take another example where my xt is a concave up, but in this way, I am seeing it's kind of like slowing. Like as x is increasing, as time is increasing, my x is going down. Tell where you will see like how it starts at positive, reach zero, and go on that. So this is a negative slope that tells you my acceleration is negative. And also keep in mind, you look at the slopes for your motion time graphs. However, you have to look at area under the curve when you go back in the reverse order. So if you're ever asked to find, given an AT curve and asked to find the velocity, you're going to find the area under the curve that represents the velocity, and the area under the curve of a VT represents your XT curve. Okay, so this is something you will be either given a problem scenario, and you will also use to ask to do the sketch a graph for a VT at two different scenarios. So you should be kind of knowing whether it's positive, where it's starting, and where it's, especially in a projectile problem, where it's reaching zero and then it goes to negative or something like that. We'll discuss about that soon. So then we move on to the big five kinematic equation. This only we will use when your acceleration is either zero or when your acceleration is constant. That's why we use your kinematic equations in a scenarios like that. So Vf equals V naught plus At, Vf square equals V naught square plus 2a delta x or 2a delta y, and then delta x equals V naught xt. And then this is your famous delta y equation. It's split into yf and y naught. If you see it, delta y is y final minus y naught equals v naught plus 1 half at square. Keep in mind, all your y direction, your acceleration is going to be negative 9.8, the gravity. However, your negative 10 is allowed in your AP exams. And the same with XF, you just replace everything in this. And remember, this A is not gravity. We're talking about horizontal accelerations. And this is your V average, velocity average is equal to sum of your initial and final, and you average it out to get your average velocity. Okay, so just keep in mind, and then all your V naughts and V naughts are your initials and VFs are your finals, and delta x or delta y is just basically your change in positions in x and y direction. And also, when we start doing projectile problems, keep that in mind. Time is the only factor that can be interchangeably used between x and y dimensions, because time is something common between those two factors. But everything else, when you are involved in projectiles, you will keep your velocities all separate. Next, we are moving on to free fall and the projectiles, right? Keep in mind that for the free fall, the only force that's acting is your gravity, which is negative 9.8, and it's always acting down. Anytime you ask for a direction of the acceleration and velocity, keep in mind your acceleration will always be a vector that's pointing downwards. And then if you analyze this, let's say if I'm throwing an object, it's going to go and change direction and come back. So when it's going up, the velocity is positive because I'm throwing up. And then where it is changing direction, remember, if I am, something is traveling positive, and then it has to go to negative, it has to cross zero, right? And then it will cross zero, and then it's going to go in the negative direction. Okay, so if I'm drawing the motion time graph for that, if you see it, if I'm looking at the slope, it's an xt graph. I'm saying it's like going positive direction and changing and coming. So if it's in VT, look at the slope of the this piece. This piece is positive and it's reaching zero. So the positive reaching zero, and it's negative, and it's going to be going on the negative side. And also keep in mind, the slope of the VT graph is going to be your acceleration. Do you see it's a negative slope? And it also matches my negative 9.8, because this is only under the influence of gravity, which is acting now down at a negative 9.8 meter per second square. So keep that in mind when you are sketching projectile problems. This is a very common thing that you will see, that where is this maximum reached. So you match the time where it's like it's going to be a slope, it's going to be zero, and then acceleration is always going to be negative 9.8 when you're asked to sketch your AT curve. The next part of the projectile we're going to deal about, like with an angle shot, right? So if it's projected at an angle of theta, so my x component, which is your v naught x, is going to be v naught cosine theta, and my y component is v naught sine theta. Usually, to find the t, the majority of the time we will be usually given a height of the cliff or something like that, or like if it's a ground to ground projectile, remember v naught delta y is zero because it's the positions are both ground. If it's coming from a cliff, you might have a net delta y, and we will always make it negative because it's final minus initial. And also, you'll always do the negative 9.8 on the A. So this is used to find the time, and t cannot be negative. Just keep in mind, if you get a t, one of them a negative value, you don't take that. Okay. And then there's another equation, v equals v naught y plus at. Anytime you use negative g, make sure it's all you're using all is y component. Like I was mentioning earlier, t is going to be the same. So I'll explain this. If you have this x and y table, v naught x is something coming from this value, v naught cosine theta. V naught y is v naught sine theta. And remember, Since we do not have acceleration acting in the x direction, it's only acting in the y direction, it will not affect the velocity in the x directions. For that reason, whatever the x velocity it's starting off, it is going to end with the same thing, which means there is no change in velocity in the x direction. Because of that reason, acceleration in the x direction is zero. Okay, and whereas Vfy will change because it's acting upon by gravity at each single point. So the acceleration is going to be negative g. And we will have x naught representing initial x and y naught representing initial y, xf representing initial final x and yf final y. However, the time is common for both things, so which means you can interchangeably, once you find the time, you can use it in either the x and y direction, the same values. Okay, I'm not sure where the video wasn't recorded. I'm just going to go back and do the projectile one more time. So this is a ground to ground projectile where delta y is 0 because its start and end points were the same. And the peak at which the velocity changes direction from positive to negative, we know that v final y, which means your velocity in the y direction is 0 there. And then you only have the x component. For that reason, velocity is minimum at y max because we only have the x component and y component is 0. So throughout the projectile, every point will have both x and y velocities except for the maximum where we only have the x component and not the y component. And also on a ground to ground projectiles, we know that it is a symmetry. So for which reason you can, if you find the time for the whole flight, I can half it to find where at what time would my maximum occur. Okay, and the other way around, you could double it for finding this and double it for the whole flight. And to find where it is being landed, like at what velocity, we will use Pythagorean theorem where you do square root of v final x square plus v final y square. Keep in mind your v final x is also the same as v initial x, as we do not make any changes due to there is no gravity acting in the x direction. For that reason, you will still use your initial x as your final x. And to find the theta at which it's landing, you do tan inverse of v final y over v final x. And in some cases, when the theta is not being given, you have to kind of know the values where you are each degrees have like a keyword to use. So sometimes they give you a keywords without giving you an angle in the problem, where they say if it's giving you a maximum range, it's going to be your 45 degrees, and 30 degree is going to be your low steep or low trajectory and shortest time, whereas your 60 degree would be your high trajectory or speed and long time. So based on that, you could use your thetas and use it to solve the problem. And I think I pretty much covered all the basics. You start working on your practice problems, and if you will have any questions, reach out. It's going to be all practice, practice, practice.